I'm Julia Masterman, and I want to tell you about the faint young sun paradox and the clues that exist in Venus's atmosphere. By studying the life cycles of stars in our galaxy, we know that stars, like our own sun, grow in size and luminosity over time. The earliest sun, for instance, was 25 to 30% dimmer than our sun is today. This raises questions about the climate of our Earth over time, because a decrease in the luminosity of the sun would mean less solar radiation was hitting the Earth, which would lower temperatures, cause freezing, and cause ice accumulation. The ice would reflect even more solar radiation, in other words increasing albedo, which would result in even less solar radiation heating the Earth. Therefore, a sun that's 25 to 30% dimmer implies that the Earth was frozen for the first 3 billion years of its existence. However, scientists now know that it wasn't frozen at this time. Sedimentary rocks have been found that date to this period, which couldn't have existed if the planet was completely frozen. Something must have been keeping the Earth warm when the sun was dimmer that isn't keeping it as warm now as the sun grew brighter. This is the young sun paradox. How has the Earth remained relatively constant temperature over time when the sun has been increasing its luminosity? Scientists have found clues to this paradox in the atmosphere of Venus. Since it's closer to the sun, Venus receives nearly twice as much solar radiation than the Earth. However, due to its dense atmosphere with a high albedo, only half as much solar radiation is absorbed by Venus than is absorbed by Earth. And yet, the surface temperature of Venus is 460 degrees Celsius, whereas the surface temperature on Earth is only 15 degrees Celsius. If it only absorbs half as much solar radiation than Earth, how is it so much hotter? The answer is in the planet's dense atmosphere. It's 90 times as dense as Earth's, which makes it great for reflecting heat, but also for trapping it. The radiation that makes it to the surface is absorbed by the planet, then re-emitted and absorbed by the CO2-rich atmosphere on Venus. As rocky planets in our solar system, Venus and Earth were formed at around the same time, and contain about the same amount of carbon. On Venus, 96% of this carbon is in the atmosphere in the form of the greenhouse gas carbon dioxide. By comparison, only 0.02% of Earth's carbon is found in its atmosphere. Therefore, we can conclude that the concentration of greenhouse gases in the atmosphere of a planet can act as a blanket which keeps the planet warm. It seems that the solution to the young sun paradox is that the concentration of greenhouse gases in the Earth's atmosphere decreased as the sun grew brighter.